Let's talk about binary math. And Zach will be here in a minute, and Chelsea will be back in a minute. Move that off of that table and set it on top of the file cabinet over there. That little thing right there. Okay. Okay, the modules, and you'll see your binary math handout. You see that? Everybody sees your binary math handout. Got that? Yep. Okay. Now you might notice that this is sort of like a, there's variations of this. There are different buses have different voltage levels, but for the most part, you got 5 volts, and then you got a 3.5 volt high bus and a 2.5 volt low bus, and then you got ground. And you talk about this is the way this thing communicates, and you can read it on a scope. Whenever I always wanted to see if a module was talking, I would hook a scope up, and when I hook, I actually had there's a breakout box you can plug into the data link, and you can hook your scope up to the whatever network it is you're talking to. Like for instance, if it won't communicate, and you're trying to figure out. I had an Escort one time, and the speedometer didn't work on it, and the transmission wouldn't ship. Right? And the guy that drew the job before I drew it just threw a speed sensor in it. And he wanted to, it seemed to work okay until they went around the building on it, and then all of a sudden the speedometer fell to 0 and all that stuff. I wrote an article about it. And so I got my oscilloscope, and I connected it to the data link where my signal was supposed to be coming out. And I was getting a nice little pattern. Whenever I would plug in and my scan tool started talking, you start seeing data. Mm-hmm. And so I said, well, why won't it wouldn't talk to the scan tool either. So you had another problem. Well, it turned out that all of those grounds that go to the negative battery cable had chalky connections in them. And all I had to do was replace that battery cable and put new grounds going in an Escort. Escort got a bunch of little black wires going to the, and whenever I have put a new battery terminal, soldered a whole bunch of wires in there with that soldered on battery terminal and connected them, just got rid of that silly connector where he had plugged them in. Yeah. And all of that came back online. My scan tool woke up because I didn't have a ground at the connector, so it had no differential anyway.
The ground will kill the whole car.
Yeah, it actually would. It can kill the car, keep it from starting, but a lot of the times it'll just, your scan tool won't talk. And if your scan tool won't talk, what are you going to do? You better be able to figure out what in the sound hill is going on. As a matter of fact, I think next week I'm going to be throwing worksheets at you with non-communication issues, vehicles that won't talk to the scan tool. And if it won't talk to the scan tool, it won't start either. You've got issues. I was driving a police car one time, and they said when you turn to the wheel, it would kill it. And then when you straighten it up, it would boom like that. And I went to the mall, and I put my breakout, box on it, my scan tool, and all that.
To the mall?
Well, I was at Bondi's. And Bondi's is right above Wiregrass Commons Mall. And so down in Wiregrass Commons Mall, before the mall opens, there's lots of wide open parking lot space out there.
Oh, yeah.
And so since I had to slalom back and forth, you don't want to do that on a public road. You see what I'm saying? So I'd go down to the mall with nothing going on down there anyway, and I'd just play around in the parking lot, and I'd turn, and nobody's going to say anything about a police car down there doing that either, you know what I'm saying, because I don't have a police car. I turned the wheel, it looked like this one out here. Yeah. I turned the wheel, and it was stalled. And I did it a few times, and finally it just died on me and wouldn't start. Well, my scan tool was dead, and I wasn't getting any reference voltage. This was bad news, so I had to call Donnie, and he came down there. And I don't remember how we figured that out. But anyway, the long and the short of it was right where the wires went back to the gas tank, the fuel tank pressure switch sensor. Somebody had put a fuel pump in, and they stretched that wire across the bracket going back to the fuel tank, and it had rubbed through until the reference voltage wire touched ground. Yeah. And it would kill it. But see, when you turn, it would make it work. Okay, now then, let me see. Huh? Look at you. Oh, you read your thing right there. See, you're number 1. You should like that. All right. Each piece of digital information that a computer knows is, see that? Look at this little table down here. All right, you see that little table I put together for you? Right there, the little table, right there. See? The first little table that I put down there under it says binary math works as follows. Okay, so you might notice that you've got your, it starts over on one side and counts over. You got that? All right, now, have you seen the switches like on that projector up there? It's got a 1 and a 0. 1 is on, 0 is off. Got it? So when you turn on, and I don't know if you've ever seen in some of these little, like I got a card in that computer out there, and it's got binary I mean, it's got little dip switches on it, and you like some of your electronic speedometers that you put on race cars and all. You know, to set it up right, you got to set it the right switches on and the right ones off. You're actually setting a group of ones and zeros, and it's creating a numeric value.
Right.
All right, so look at this. You're going to see in some of your troubleshooting that we used to more than now, they'd say whenever the wheels were turning and you were reading the sensor, you know, as the computer was seeing it, you were actually supposed to see a value between 0 and 255. Now, do you see how that comes from? See that? You got a most significant number and a least significant number. You see those? All right. Now, if you're going to notice, and that's just what I was talking about there, if you've got these values here, like on the very bottom in table number 1, you got a 1 and a 1 in there. See that? All right, well, that 1 and 1, what's the value of that binary word? You don't add the ones that have zeros under them. You only add the ones that have ones under them. 1 and 2 is what?
3.
3. Okay, you got that. Now look at the one. Look at the next one. Look on table 2. All right, I want you guys to figure out table 2.
That's on the back.
Yeah, it's on the back of that handout. See table 2. I want you to do the math and tell me what the what's going on there. You got that? Yeah, I've already got the answer there, but you can see it. You see what I'm saying? You got a 1 under your 1 and you got a 1 under your 16. So the value of that binary word, see, this is an 8-bit binary code is what it is.
Hold on now. How's it? Okay, 1 and 1. That's 2, right?
Well, no, you're actually adding the ones that are in the box above those ones.
Okay, so just whatever one's got a 1 under, we add all those together.
You're going to add those together, and that's going to give you your number. Okay.
Yeah, well, there's a 1 under the 1.
Yeah, I know, but the one, the bottom, in the bottom part of that, the only values that can be in that bottom are ones, and 1 or 0.
Count the 1 as a check mark saying add these numbers together.
Yeah. The numbers that are above the ones are the ones you're going to add together. If there's a 0 under the numbers, you're not going to add those together. Okay? See what I'm saying? So you only add the ones that have a 1 under them in that table. That's how that works. And that's pretty cool.
So this one is what, 65 and 17 for the next one?
Yeah, the next one, table 3. Somebody give me a value on table 3. What is it?
81.
How you get 81?
Because there's a 1 under the 1 too.
Yeah, 1 and 16 is 17.
Yeah, 64, 16, and 1.
Yep, and that's 81, isn't it? Okay. That one there, the value of that one, that next one, which is table 3, is 81. Are you confused? Yeah. Somebody get over and do a little tutoring for me with that. I think Matt's going to give him a hand with that. All right, you guys figure the rest of them out. We can blow through this pretty quick. What's the value of table 4? Remember what it is when you add them all together?
So you don't add 625. So it wouldn't be nothing.
Yeah, it's 255. Right? Have any of you guys ever set up IP addresses on computers or anything? You notice how a lot of the time you'll see 255, 255, 255, 0, and this kind of stuff for your subnet
I have a
mask.
generator.
Yeah, so that's what that is. You know, that's what I mean. You're 8-bit binary code. That's what you're doing. Whole deal. You're seeing how it works. Okay, what about table 5? What you got in there?
85.
Very good. Look at that. 1 and 4 is 5. 5 and 16 is 21. 21 and 64 is 85. He's right about that. And then see how quick that is and how fast. Now table 6. Somebody give me the answer in table 6.
224.
Well, you got 32 and 64 is 96. And 96 and 128 is what? 224. Listen to that math whiz over. He's just whooping it out. Computers can add and subtract really, really fast. They use exactly this same stuff when they do their multiplying and everything, believe it or not. That's what binary code is all about. Now then, let's see how swift we can go through here, and we've got lots of stuff to do in the shop, so we don't need to belabor these a whole lot, although if I think of a pertinent story to tell, I'm going to tell it. Okay? You got that?
We've understood that by now.
And I can do that because I'm the boss. And y'all aren't.
Yeah, you're going to do whatever you say.
Yeah, and an operative horn is being tested. And an operative horn is being tested. A digital voltmeter placed across the relay load contact terminals, which the load contact terminals on a relay is going to be let's say this is the relay that we're going to be using. The load contact terminals are the common and the normally open. You're going to see that up there. See that? That's a load contact terminal. Okay, you're hearing it.
Camera can't see that over there.
Huh?
Camera can't see that over there.
Yeah, I know, but y'all can. The camera saw this. See what I'm saying?
Why can't the camera
So
see
basically, you got coil, common, and normally open. Okay, now the one in the middle is normally closed. You hear a click. So you showed 12 volts. Now, if you've got 12 volts going to your horn, but it don't blow,
Something's wrong with it.
Crappy horn.
now wait a minute, you're across the load contact terminals. Think about what you're doing here. All right, watch this. I'm going to have to draw this.
Thank you, sir.
We're going to draw it like it was a schematic. All right. All right. That right there, this one here is, let's just say that, let's just draw it without that other terminal. This is the only terminals we're going to use on that. Okay, we got B plus coming in here, and we got a horn button coming in here. I'm going to make sure that my camera can see it. The horn button, the horn switch is going to ground that relay, and it's going to cause this coming here. You got B plus here, and what do you have over here? Down here,
Going to the horn.
you got a horn.
Yeah.
Right. All right, now I'm going to measure from here to here, right? And I read 12 volts. Got that? Now, when I energize the horn, it says I'm still reading 12 volts. But the relay clicks. I hear the relay click. What's that telling me? That tells me this coil's okay, and that this is even moving.
The horn's back.
Well, wait a minute. Why am I reading 12 volts here? Should I read 12 volts here?
No.
That's voltage drop. I'm dropping every bit of the voltage right here in this relay. We got dirty contacts. Got it?
Wait, what? You got 12
Yeah, the
volts.
contacts in the relay's back.
Yeah. If I've got 12 volts here, where's my ground coming from? My ground's coming from the horn, which is grounded. Okay, so I got a ground coming from here. I got 12 volts coming from here. When I close the relay, that 12 volts should go away. Shouldn't it? Because that ground is neutralized and the horn's blowing. Yep. Now, what I usually do, I'm going to tell you what I usually do when I'm troubleshooting the horn. I go down there to the dadgum horn.
Yeah.
And I just see if there's power there, power and ground there. Power and ground at the horn, it lights up, usually got a bad horn. Here's a rule of thumb. Here's Richard's rule of thumb on troubleshooting electrical systems components. The component, and this is a precept. I mean, this is a principle, it's not a precept. A precept is when everything is always this way, right? But a principle means you can usually regard this to be the truth. Whatever component is in the most hostile environment and is working the hardest is the one that's going to fail.
Yeah.
You understand what I'm saying? The fuel tank sending unit is likely to be the cause if your fuel gauge ain't working, because it's in a hostile environment, it's working its fanny off. It's going to fail. The gauge doesn't usually go. It can, but usually it doesn't. And that's what I'm saying.
I mean, what you're saying.
Question?
What would be the main cause if an entire dashboard didn't work?
On what kind of vehicle?
A Civic.
Huh?
A Civic. Not a 2000 Civic.
Oh, a 2000 Civic?
I think it's 2000.
The first thing you do in any situation like that is powers and grounds.
Check your fuses.
Powers and grounds, yeah, fuses. You check your fuses.
We replace all of them.
There was a girl here one time that was in the program, and she called and she says, my transmission won't shift. And my daddy says, we're going to have to do a transmission job on this car or something like that. It's some kind of a Pontiac Grand Am or something. I says, why don't you check your fuses? And her daddy said, that's the stupidest fool thing I ever heard. I don't know why in the Sam Hill he's even wasting your time. And she checked her fuses and found a blown fuse, and her car would shift again. Well, I mean, the transmission solenoids weren't fired up, and it's in high gear all the time. Okay. Now then, number 2. Let's hurry. I'm taking too much time. Technician A says when testing a grounded, Number 1's A. Technician A says the relay is bad. See, because he's dropping. This is a voltage drop thing. If you're reading 12 volts there, when you measure from here to here, you're dropping all 12 volts across that relay, even though the relay clipped. Technician A says when testing a grounded circuit, if a fuse blows as soon as it's installed, a short to ground is indicated. I would say he's pretty well on target, right? Yep. If you put a fuse in there and it goes pop, you're going to blah, blah. Technician B says the component will not turn off if the short to ground is on the ground side of the load component, but before a grounding switch. Now that is a complicated question.
Yeah, I don't get
But
it.
if it's, well, watch this. Let's go with our relay. What if I grounded this right here?
It's gonna always click.
I mean, you're going to be blowing the horn all the time. That's right. You ever do that? Okay, that's what the deal is. I mean, that's basically number 2. That's C. Yeah, all both of them. Right. Technician A says both an ohm meter and a self-powered test light may be used to test for continuity. You know what a self-powered test light is? It's a test light with a battery in it. Well, no, a self-powered test light's got a battery in it. And basically, the way the self-powered test light works is you've got a wire and you got a probe and you got a battery with a little light in it. And when you touch these two together, it lights up. You don't hardly ever see them because nobody uses them. You know what I mean? Now, they have a self-powered test light where you can lay your hand on ground and just touch this to your hot and it'll fire up using you for a ground. It's got a little LED in it, yeah. Snap-on used to sell them. They weren't real popular because it was on the ones that they originally sold, you couldn't check for power. I mean, you couldn't check for ground. You couldn't touch power and check for ground. You know, I guess later they may come out with something like that.
The power probe thing, I find that's the easiest thing ever.
Oh, man, it's wonderful. Yeah. And,
Michael's got one. I use it all the time.
Yeah, we got 2 of them here. All right, number 3 is, see, a power probe actually has a little meter built onto it, and you can actually feed power and ground in there.
What is continuity?
Continuity means that it's together. You got a straight circuit all the way through. Right. Number 4, a voltmeter. A voltmeter placed across the terminals of an inoperative electric window motor indicates 12 volts when the window switch is depressed. Technician A says the window ground circuit may be faulty. Technician B says the window power feed circuit may be faulty. Now, see, these questions are some that I've just about got to draw a picture for you to understand. Okay, I got a motor here, and that motor's got 2 wires going to it. Most power windows. Ages ago, GM used to have 2 wires go in, 3 wires going to their motors, but most all motors nowadays. Okay, so I got a connector here, and then I got a connector here coming from the car. All right, so if I hook from here to here, and I read 12 volts, right, when you operate the switch, what does that mean? That means you got good power going to your motor. If it ain't working, you got some issues. I tell you how I like to do this. This is Richard's trick for checking power windows. If you pull that trigger to move that window, and you're watching the dome light, and it gets dim, you know you got good power going all the way to your motor. Yeah. In most cases, I mean, occasionally you'll have a ground somewhere, and all that. But in 9,900 times out of 10,000 or whatever, you're going to have. If you pull that trigger and that light goes dim, you know there's power going to the motor. Now, you may have a bound-up window regulator or something, but most of the time your motor's just, You ever seen them where a lot of these vehicles now, this flocked run that the window goes into will get sticky? Yeah. There's nothing wrong with the motor and everything, but it's just stuck up in there, so you got to get it out. Well, what happens is it's just hung in the very top. Yeah. My wife from the Explorer does that, and I had to tell her to roll the windows down some so that they don't get stiff. Air conditioning all the time. All right, now, let's see. Indicates 12 volts when the window switch is depressed. Technician A says the window ground circuit may be faulty. That's not true, or you wouldn't see 12 volts. Technician B says the window power feed circuit may be faulty. That's number 4. That's this right here is a D. Neither one of those, neither the ground or the power circuit is faulty because you wouldn't see 12 volts if it was.
Your answer said you were number 3.
Huh? Basically, number 3 is a C. Both those guys are right. Number 5, the leads of a digital multimeter with a diode check function are placed across the terminals of a diode and then reversed. A 0.6 volt reading is obtained in both directions. Technician A says this means the diode is shorted. Technician B says that means the diode is acceptable. A is the only one that's right in there. Because when you've got diode check, you're going to be reading usually about 0.6, You can check an alternator that way. You know what I'm saying? Listen to this. You take your main big terminal. Now, this is important, so pay attention. Get your diode check. Are you listening? Get your diode check and hook it up, and hook up one lead to the positive terminal on the alternator and the other lead to the body of the alternator. And then swap them. One way ought to read nothing, the other way ought to read about 0.6 of a volt. Now, basically, all you're checking is the diodes. Right. But here's the thing. If it checks the same both ways, that is a bad alternator. End of story. See what I'm saying?
Hold on now. Which one would you put?
The big, like on the alternator, if you take your alternator and you got a diode check function on your meter, all right, you got your alternator here, and you got your old big wire that goes to the battery.
Goes to battery.
All right, so you're going to hook your lead right here, and with your diode check, you're going to read about 0.6 of a volt.
Hold on. What are you hooking the other wire to?
The body of the alternator, the shell.
Okay.
Because you're actually checking the diodes.
So what do you swap around? That's what I want.
You just swap them because the diodes are only supposed to let power go one way. And you're actually, when you go from here to the body, you're checking all the diodes at once. Now, I will tell you this: you can actually have an open diode amongst that bunch, and it won't do that. But if you ever check one, this is one of those tests that's only valid when it fails it. Make sense? Mm-hmm. Now, you can check it both ways and it have 0.6 of a volt one way and it be open the other way, and that doesn't mean the alternator's good. But if you check it and it's got 0.6 both ways, you know the alternator's bad.
Yeah.
So it's only a fail. It's only 100% when it fails. But the rest of the time, you got a bunch of other crap in the alternator that can go bad. All right, number 7. Okay, number 5, I'm sorry, was A. Number 6, the technician A says maximum current flow will flow through 0 ohms of resistance. I'd say that he's probably pretty correct about that, wouldn't you? Technician B says infinity will not allow current to flow. Both of those guys are right. That's a C. Number 7, technician A says a stepped resistor should be disconnected from the circuit before testing it. What is a stepped resistor?
Means like a
Blower motor. Blower motor resistor. All right, now for Jacob, watch this. A stepped resistor is like that. Okay, now you've got places you can run juice in like that. All right, now if I'm going right here, let's say I've got my blower motor is always powered up and I've got ground coming through my switch. Now, if I'm on low blow, all of that current's got to flow through all these resistors before it gets to the blower motor. That's going to make it run slow, isn't it? If I click it up one, I've taken one resistor out of the loop. I click it up another one, take another resistor out of the loop. Finally, I click up this one on high blow. You understand that? You got it? That ain't complicated, is it? Jacob usually catches on real fast. If you just take the time to explain it, he gets it the first time. You know what I mean? All right. That's how that works. Okay, now then, so if you need to take it out, any of these things like that, you need to take them out of the circuit before you check them, which is all there is to it. I mean, that's my rule. Technician B says a relay may be tested while it's connected to the circuit. Number 7. Now, both of those, well, actually, you can check the relay while it's connected. If you do it the right way. To begin with, you just about got to have one of them things like I got in there where it exposes all the terminals. Yeah. You know what I'm saying? And if you can energize it really artificially, you can tell. I mean, that way that's what they're talking about. Number 8. I got a thing that goes between the relay and the place where it plugs in. All right. Yeah, that's what I'm talking about. What will a Zener Diode do at breakdown voltage? Now, in order to know that, you'll have to know what a Zener Diode is actually going to let voltage flow only one direction until the voltage goes to a certain level, and then it can flow both ways.
Okay.
See, and usually when you see a Zener Diode, it looks like a regular diode, except it'll look like a little piece of amber glass.
But what is that? What's that used for?
It's used for like temperature sensor circuits or anything like that.
Oh, okay.
There was this one guy that was a psychologist out at Fort Rucker that came to when I was running my dad's shop for a while he was in Tennessee. He had actually took a little Zener diode and a temperature sensor put on the cylinder head, and he actually had a little alarm that would sing up here whenever the cylinder head got too hot.
Really?
Yeah, he was pretty cool. That guy knew stuff. He was a sharp cookie. But anyway, that's what a Zener diode does is it allows reverse current to flow when it gets to a certain voltage. So if you got a Zener diode that's rated for like 13 volts, that current goes up to when it sees 13 volts, it'll all of a sudden let it go both ways. And that's basically used for voltage regulation and stuff like that too.
You could take one of those and hook it to your temperature sensor unit, and when it got too hot, if it got too hot, it would make a noise.
Yeah, if you wired it up right, yeah, you could wire it up so that,
How would you do that?
Well, you'd have to wire it up so that the voltage that was there would change up to a certain, and then when it came back through it would energize a transistor, and that transistor would be driving a buzzer. See what I'm saying? You'd have to have a thermistor of some kind that's actually going to have voltage fed to it, and it's going to let the voltage slowly climb, and when the voltage coming in to that thing is that side of that transistor gets above the voltage it's rated for, it's going to let it go through and close the transistor, and then the transistor is going to light off your buzzer. You could draw a schematic, and I think, if I'm not mistaken, guys, there's a Zener diode in and amongst those components you got on that live wire thing.
Where do you get that live wire thing?
I bought it from New Wave Concepts for $600. Yeah. So okay. Now then, all right. Now then, we got number 9. Technician A says damage can occur on solid state circuitry if the charging voltage is allowed to get too high. That's a no-brainer. You can blow all the headlights and stuff if the voltage goes way too high.
Which one are we doing?
Yeah, we're doing number 9. Technician A says damage. B says damage can occur if the vehicle is allowed to run with the battery disconnected. Both of those guys are right.
What will that do if you do it with the battery?
The alternator will spike, and it won't always do that, but it's just a bad bet. It's kind of like taking your paintball gun that's got a revolving cylinder on it. You say, well, I got away with it 8 times. Let me try it again. Boom, so it gets you. You know what I'm saying? That's what that's doing. How many of you have ever seen an old timer take the battery cable loose to see if the charging system was working? That's just what we used to do. You know what I mean? We could also hook the car up 24 volts and spin it real fast and get it to start, too. Can't do that stuff no more. Too many electronic components. Yeah. You know what I'm saying? Yeah, if you got a good, strong battery on the car. Let's say that you got one like the old cars when the old high-tension rings were dragging on the cylinder wall, and they had let the oil got off of it. And, like if the car hadn't been started in a while, and you're trying to start it, it goes, rah, 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 rah. You ever heard that? You're trying to start a car that ain't been started in a long time, or somebody's been trying to start it till they got gas going in, they wash the cylinder walls down, they go, rah, 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 rah. And in the 1960s, when nothing was electronic, and we would take the battery, whenever we'd take, and my dad would do this, I'd seen him do this, he would take like the negative battery cable off, and he would hook the positive battery cable to the negative battery cable on the battery and hook the other one to the cable he took off of there, and now he's got 24 volts. He wired batteries in series. And it'll I mean, it's spinning twice as fast, But don't try that on anything that's got anything electronic on it, or you've cooked it. You got that?
Yep.
But somebody gave me a 24-volt Jeep battery one time. It was a military-grade thing. I just carried it around in the trunk of my car. And when somebody needed to be jumped off, I'd hook that sucker up and just about throw the motor out of the car. I spin it so fast, And they'd jump off a bunch of cars, But I don't even remember what I did with that dadgum battery. But anyway.
You tell him, I'm not going to hook it to your...
Yeah.
To everything, because it's probably going to kill it.
Yeah, it might because of the explosion. Technician A says a Zener diode is an excellent component for regulating voltage. Technician B says that when a circuit is opened suddenly to a large load, such as a coil, installing a clamping diode provides a bypass for the electrons. Both of those guys are right. Now I'm going to show you what a clamping diode is. You remember I told you the other day that whenever your injectors would de-energize after they've been energized, they'd have a spike? And this is a story that I tell sometimes about the cable TV truck that kept eating radios. Brand new Ford truck. They said we had to put 3 radios in this thing over the past 3 months. It lasts about 30 days and the radio craps out. And it's a bad radio. So I found out the power takeoff for the hydraulics on that bucket truck were being driven by an AC style clutch, which is a winding that's going to pull a hub in and all that kind of stuff. Okay, and they just basically hooked it up to a switch. And this right here was grounded. All right, but that power that they were using, some kind of a way, I don't remember how they did that. But anyway, the fact is, whenever they would, the way they had it wired up, when they'd switch this switch off, this spike would go screaming back into the radio. It was like 400 volts. And the radio could take some of those. Bam, bam. It'd take a punch or two, and then finally we would go, And so, well, what I did on that was, I took a diode, and I put it in here like this. We're going to zoom in on that. We're coming in here. This is minus, this is plus. I put a diode right here like that. And what that did, whenever that magnetic field collapses, when you switch off that current flow, you've got a saturated winding. And whenever that magnetism goes away, there's a spike that is created just like an ignition coil makes in that winding. And it comes blowing back out of there super fast. These relays, because they're worried about that happening with them, and I can't believe that really fell in that dadgum bucket. But anyway, these relays, you might notice, even on the wiring schematic, will show, well, usually they do, since I'm wanting to show you one. That one, they got it. But anyway, they'll actually show a little resistor jumped around the coil, and that's what it's for. It's to keep the spike from going back into whatever computer or whatever's operating the relay, because you don't want that to happen.
Right.
On the starter relays on some of the Fords that didn't have electronic fuel injection on them, they didn't have to worry about that spike.
Right.
Well, somebody brought this Aerostar in there, and they said sometimes when you start it runs just fine. Sometimes when you start it runs like crap. And so I noticed it had a brand new starter relay on it. Put my oscilloscope on it, hooked that starter up there to the starter relay, and whenever I energized the starter relay and then I de-energized it, I saw a big spike. And I said, that one doesn't have a clamping diode built into the relay. And it was every time that wire that's going over there that comes from the starter, it also goes to the engine controller. And every time that spike would come screaming out of that coil, it would go right back into the engine controller and it would punch it in the jaw. And the engine controller sometimes would go blah, 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 and wouldn't know what to do, you see. And it's just the way that goes. You've got to make sure that there's no spike. Now, it's designed to absorb the ones that come from the injectors. That's a 50-volt spike, but it can handle it. If it's not set up to handle it, though, you got to do something with it. The idle air controls have got a little diode in them because they're switching off and on so fast they don't want them spiking, because that's like a bunch of punches, like Popeye,
Right.
So anyway, but if you put one on and you wire the wires up to it backwards, that diode lets the current go through and it pops the fuse. This electronic stuff is not complicated if you just have somebody explain it right. You know what I'm saying? And you'll start building on what you understand. Number 11. Technician A says to test fuses, you could use a voltmeter or a test light. Technician B says a voltmeter and a test light are hooked in parallel. Hooked in parallel. Number 11, that's actually C. What does that mean by that? A voltmeter and a test light are hooked in parallel with what?
Hooking together with a circuit.
Well, basically, parallel means that you're hooking it up parallel with your load for the most part. Now, here's a little electrical trick I was telling them guys about, and I mentioned this last semester. And you remember I told you about this. Let's say that your fuse is, you got a fuse, and that you got two terminals for a fuse. One of them's got power coming in, one of them's got power going out to your load. Got it? Yep. Everybody listening to this, it's important. Jeremy, you ain't sleeping, are you?
Get on, Jeremy.
Jeremy's hiding from me. Well, Jeremy, I need to move you somewhere where I can watch you because you're dozing.
Concentrating on his paper.
All right, now watch this. He's got his part. Y'all nudge him if he tries to sleep. All right. Now you see here, I'm going to take this terminal right here, and I'm going to get a jumper wire, and I'm going to connect it to the antenna wire on my radio. Out there, I'm talking about on the fender. I'm just going to hook that jumper wire, alligator clip, to my antenna. This sounds weird, but I'm going from the shorted part. When I plug it in and it pops a fuse, I'm going to hook it to the jumper wire. I'll jumper it to my antenna. That particularly, you understand what I'm saying?
Yeah.
All right. And then I'm going to turn my radio to the low end of the AM band, all the way to the low side of the AM band. This is as low as I can go, because that's really susceptible to electrical interference. That's the same kind of thing that the jets that we used when they were painted by radar, like if you were flying a jet in Vietnam, they had a low end AM radio, and you'd hear this squawking sound because when they painted you with radar, that low end AM radio, and you know that the sound was headed your way, and then you could dodge it if you were a good enough pilot. But anyway, the long and the short of it is, you're going to get an old remote, your old TV that you got in the garage that you ain't using no, but the remote's laying there with it, and put good batteries in it, and hold it by this antenna. When you mash it, you'll hear the radio go and just make a terrible noise. And so then you're going to follow the place where that wire harness is. You're going to know which way it runs. If you look in your book, it's going to show you it runs down this side and it goes up there. Yeah. And you go down there just mashing the buttons on that remote. When you come to the place where the short is, the body of that car will pick up that signal and it'll send it right into that fuse. Say, aha, I know it's right here somewhere. It's like you got a short detector. You probably won't get that little trick anywhere else. But I actually learned it at a Chrysler school. I thought it was pretty cool. And you can demonstrate that. You know what I'm saying? If you just next time you want to play around with something, you can find you a remote that'll make a bunch of racket. When you turn the radio on, put it on the low end of the AM band, hook this to the end, and just pull the trigger by your antenna out or see if it makes it raise a cane. Aha, here's my, That's cool.
Listed it. It's cool.
Huh? Yeah. Number 12.
Well, I'm gonna do now.
So number 11 is C. Number 12, to use a transistor as a simple solid-state relay, what conditions must occur? Now, let's just make sure everybody's on the same sheet of music. A transistor is basically, the schematic for a transistor is like that. Now, a transistor is going to have three terminals going to it. And this one right here is the base. Now, if the base is always going to be the opposite pole of the two others, right? So if this base is positive, then these right here will be negative. So this is an NPN. Got it? If both of these are positive, let me tell you what it does. This is NP. This is PNP. See, PNP. You understand that? You're going to see something in your book sooner or later talk about a PNP transistor or an NPN. Okay, if I ground this, let's say I've got, this is, one of these is the collector. If this is positive, a collector, we'll put it up there. And this right here is the emitter, and this is the base. Now, when I ground that one on a PNP, what's coming in here is going to go out there. There's not going to be anything here until I ground this. You got that? That's how a transistor works. Real simple. So when I ground the base, what's coming in the collector is going to go out. If I've got the NPN, when I put positive juice into that base, the ground, this is going to be the other way. That way, the collector will send the ground out that way. That's what a transistor is like a little miniature tiny relay with no moving parts. It's a semiconductor is what it is. All right, now then, number 12. To use a transistor as a simple solid-state relay, what conditions must occur? And the right answer to that is the emitter-base junction must be forward biased and the collector-base junction must be reverse biased. We're in automotive electronics too, okay? Remember what I was just talking about here? You know, all right. Now, do what you will with that. But, you know, you're going to, if you're reading the chapters in the book, you're going to get more information than I just gave you. So the book is going to help you with that. That's why you need to be reading the book. Technician A says a shorted circuit can generate excessive heat. It will burn something up. Technician B says a shorted circuit will cause the circuit protection device to open. What's a circuit protection device? Fuse or a circuit breaker. That's right. Okay, number 13 is C. That's going to be both of them. Which of the following is true about a clamping diode? Number 14. It's used to protect some solid-state circuitry. I just talked about a clamping diode and how it punches the computer in the teeth or the radio or whatever's up into there. How much resistance is in a 12-volt circuit that's drawing 4 amps? Remember your...
3 ohms.
Yeah, number... he's right about that. 3 ohms even. An even 3 ohms. Got that? So you got 2 of the pieces of information you need, right? A voltmeter that's connected across the input and output terminals of an instrument cluster illumination lamp's rheostat indicates 12.6 volts with the switch in the maximum brightness position. You know when you're turning your knob on the dash and you make your lights go bright and dim, basically? What you got there is you got a resistor. And you got your power coming in, and it's actually going to go out here. And the more you use this one right here, on a TP sensor, this will be grounded, but on the rheostat, it's not. This is just wide open. So the farther away from that voltage you go with your slider, like my slider would be like my marker here, the farther I go, the more power comes out here. As I go down, I'm dropping more voltage across this resistor, which is like a coil of wire, basically, with a point sliding on it. So if I go up here, it's going to be really good and bright. If I go down here, it's going to go all the way away. Got it? All right, so let's look at number 15. 16. A voltmeter connected across the input and output terminals of an instrument cluster illumination lamp rheostat indicates 12.6 volts with a switch in the maximum brightness position in the engine off. Which of the following statements is true? B, the voltage available to the lamps will be 0 volts. Now, why are you reading that? You're reading it. Why did we read the 12 volts on the relay in the first question? We're dropping all the voltage. You're measuring voltage drop here. Got it? When the brake pedal is pressed, the left rear and right rear tail lights and the left rear and right rear brake light of a vehicle illuminate dimly. Technician A says the brake lights may have a poor ground connection. Technician B says the brake light switch may have excessive resistance.
Technician A.
Technician A, very good, Matt. Outstanding performance. Matt had it. He had that one by the tail. All right, now let's look at number 18. The horn of a vehicle equipped. Oh, let me tell you this brief little story. These people, every now and then, we would have somebody that would say, that would come to me when I was working it. I was the kind of the go-to guy for a while at the Ford place over, and they'd say, when I mash the brakes on this vehicle, the dash lights come on.
They what?
When I mash the brakes, the dash lights come on.
What?
Yeah, and this happened fairly regularly. Not, it happened more than once. I mean, I saw it several times. And they'd say, "Where do I start looking?" So what you going to tell them? This was
Check the bulbs.
yeah. Pull the bulbs out in the back, all the bulbs.
Oh, yeah.
And you pull the bulbs out. If you pull the bulbs out and it don't happen, one of the bulbs is bad. It ain't complicated. The little wires inside the bulb are touching together, and it's back feeding into the. See, what you don't recognize is the tail lights are coming on too. See, that's a separate circuit from the front park lights typically. I mean, it may be or it may not be. But anyway, now let's move on down here. Did you get anything out of this?
Yeah.
Everybody, you're soaking stuff up, right? That's what I'm trying to get you to do. That's what school is all about. Some of it is going to be in here.
Hey, girl.
Now, Jeremy, usually when one of these talks of mine goes a little too long, Jeremy and Chelsea will turn into a skeleton. They'll just sit there and dry up boiling. All right, let me see. The horn of a vehicle equipped with a horn relay sounds weak and distorted. Which of the following is the least likely cause of the problem? Actually, excessive voltage drop across the relay coil winding. A coil winding is not going to make the horn sound any different if it's sounding like anything at all. Okay, 19. The circuit breaker that protects a power window circuit opens whenever the window is lowered. Technician A says the internal resistance of the motor is too high. Technician B says the window regulator may be sticking. B. The internal resistance of the motor being too high is not going to cause a circuit breaker to open. Why? Because current flow is going to be lower if you got a high internal resistance, right?
Yeah.
Okay, so 19 is B. Number 20, the current draw of a window motor is being measured. Technician A says the ammeter can be connected on the power side of the motor. Technician B says it can be connected on the ground side. Either side, it don't matter. Now, when I'm talking about hooking the ammeter up, I'm going to try to make sure I fill in as many of these holes as I can. You got inductive ammeters that you can put around the lead. And you can also disconnect that wire and hook the ammeter up between if it's one of those kinds. Okay? All right. Now that one, that's going to conclude that test. We need to blow through that next one real quick because I'm sorry about all this, guys, but we've only got 10 weeks in this semester and it will be gone before you know it. All right.
Richard.
Yeah.